Good morning. We start in 2 minutes. So let's start with our today's session. Very good morning. Here is my brief introduction. So welcome back. Now this is the third session in Masterclass Tag series. Now if you see, today we'll be talking about 5 foundations of networking. These 5 topics, they are so important that once you know them, it will create a very solid platform for you to understand so many advanced technologies into the networking. And you'll be surprised that these topics, they'll be used again and again as you proceed learning into the field of networking. Now, some things which are taken as a prerequisite. One is that you should be pretty comfortable with the IP address. Now, we won't be going into the calculations of IP address this time, because we discussed IPv4 in our first session and IPv6 into the second session. But today we'll be talking about actual implementation. At the same time, many of those concepts, as we talked about, that they are the foundation of networking. So let's start. Now see which topics we'll be discussing today. Say, for today, as we said, that these will be the 5 foundation topics. Now these 5 topics, as such, they are interconnected with each other. So it's like we'll start with, say, OSI layer, and in this OSI layer, that is, there are 7 OSI layers, we'll club it with that what exactly is the difference between router, switch and the hub. And along with this, we'll be talking about that what is a broadcast domain and what is a collision domain. Now once these topics are done, we'll talk about DHCP, we'll talk about DNS. Now because these topics, say they are related to each other, right? So we'll try to discuss it in such a way so that there is absolute integration between and absolute good understanding between that how exactly are they functioning. All right. Now see, for the OSI layer, we start with a very basic OSI layer. OSI, its full form is like Open System Interconnect. But they say that this is like a layered approach. Why we really do need these layers? When we say networking, to networking we should feel like that, okay, this is one system and it is talking to another system. Where are the layers? These are all virtual layers. Importance of virtual layer is that whenever you will be going for the troubleshooting, it will be helping you a lot. It is very important for troubleshooting. And second interesting thing is that they are divided into two parts, software part and the hardware part. This will give you a tremendous advantage, that is about understanding of that where exactly these devices work. So let's see. So these are like 7 layers. Now these 7 layers, 7, 6, 5, 4, 3, 2, 1. They are divided into two parts. This is what is called as the software part and this is called as the hardware part. It is this area we are interested in for today, the hardware part, because we wanted to know the difference between router, switch and hub, right? So let's say this is layer 3, layer 2, layer 1. Now as we said that they are associated with hardware, right? They are associated with hardware. Now in networking you will come across routers, switches, and nowadays you don't see hubs more, but well, these are the 3 things which are very closely associated with the networking component: routers, switches and hubs. For the ease of understanding, remember that this is where the hubs work, this is where the switches work, and layer 3 is where the routers would function. To make it still interesting, this is where the IP addresses would work, whether it is IPv4 or v6, and this is where the MAC addresses will come into picture, MAC address, and this is where your cables will come, or the physical connectivity. That's the reason the name of these layers are like physical layer. This is what is called as the data link layer, and this is what is called as the network layer. So this tells us that these layers, they have got association with this specific hardware. Now when you go into the market and you say that I want to buy a router, you go into the market, you say that I want to buy a switch. This cost of this router, cost of this switch, it varies tremendously. Now there would be few switches, they will be costing in lakhs. There would be few routers, they will be costing in just few thousands. Well, it depends. It depends upon the capability. But over here today we'll be talking about that what exactly is the fundamental difference between router and switch. One difference we understood that okay, this would be working at layer 3 and this would be working at layer 2. So in this case IP addressing is more important, and in this case MAC address is more important. All right. Let's draw. Say this is our hub. I'm starting with the device which has got least functionality. So we start with hub, and as we said that hub works on layer 1. Now literally hub has got no intelligence. The hub is literally not understanding what these devices are doing, what these computers are doing. They'll simply let that message go from one point to another point. So for our understanding, we are putting 3 machines. Let's put them like system 1, system 2, system 3. When system 1 is interested in talking to system 2, right? I'm writing here system 1 wants to talk to system 2. Hub would say, I don't mind that the message is going to system 3 also. So it would actually go to system 3 also. This is something what is for what is happening for the first time. It's going from S1 to S2 and S3 all. But in case of hub, it's not once, it is always. It is always, whether it is happening for the second time or it is happening for the 200th time or 2000th time. Every time the message which has been sent from system 1 to system 2 will also go to system 3. Now in order to explain these things in better way, some names are given. First time when it is happening, so then it is called as the broadcast domain. Broadcast domain. And from second time onwards, it is called as the collision domain. Now domain means area. Domain means area, right? This is domain is area. So for the first time, if you see, it is like from system 1, the message is going to system 2 and it is also going to system 3. That means this entire area is one only. There is only one area. They all are part of one area. Let's say if there is one more device, that is say system 4, right? If we connect system 4 over here, no problems. Even when system 4 is connected, to then this message would be going even into this system 4 also. So in nutshell, this is the entire thing working as one area. So that is what is called as the broadcast domain. Now when it is happening for the second time, right, second time onwards thing, which is called as the collision domain, as we said, this is happening always, whenever, even for the 2 millionth time also, if S1 is sending any message to S2, it is going to S3 also. So in this case, this is going for S1 to S2, but it will go to S4 also, but it will go to S3 also, it will go to everyone. So that means we have got, in nutshell, one broadcast domain and we have got one collision domain. Because hub has got no control, it is practically sending the things to everyone. Moving further, so we'll just write it over here that in case of hub, broadcast domain and collision domain, it's 1 1, right? It's 1 1. Now let's talk about switch. Looks wise, hub and switch, they look so similar because both of them, they would look like that, yes, this is a box and on which there are multiple ports. But internally, when we talk about switch, there is something different. There is what is called as the ASICs. A6 is a special chip. It's a circuit. It's a special circuit. And this is called as the application specific. And because this is IC, that's why it is, say, integrated circuit. Right? It is integrated circuit. So that's why it is application specific integrated circuit. Now what it does, as we said that switches, we are dealing with switches. Switches, they work at layer 2. Layer 2 means they will be dealing with MAC address. When they are dealing with MAC address, we know that this MAC address is a unique name. It's a unique identity of every device, every machine. And this unique identity is a 48-bit address. This is so unique that even if there are multiple interfaces, every interface would be having a unique ID, a unique MAC address. Now in case of switch, this is what is happening. Let's connect a switch. We are just replacing hub with a switch, and let's say this time we also connect S1, and let's say this is the port number 1, right? This is, for the ease, I am writing this like number 1. Otherwise it could be like 1 by 0, 1 by 1, 0 by 1, 0 by 2, etc. But today we are understanding the concept, so we are making it as simple as possible. So this is S1. Let's say this is S2, S3, right? Let's put this at port 2 and port 3. Now here starts our first journey. S1 wants to talk to S2. Yes, it would go from S1 to S2, and it would go to S3 also. Is it like hub? Yes, exactly. It is behaving exactly like hub for first time. And first time was called as the broadcast domain. Am I right? It was called as the broadcast domain. So it means in case of switch also, this entire area is behaving as if it is one only. Very true. It is behaving like as if this entire thing is one. There is only one area. So this whole thing is one broadcast domain. So over here we'll say yes, one broadcast domain. This is like hub. But now that special chips comes into picture. It is what is called as the A6, as we said. The function of A6 is to prepare MAC table. MAC table or MAC address table, also called as the filter table. But what exactly it is? What it is doing is, it is making a table, and on one side there are ports, and over here there is MAC address. There is also a concept of VLAN. VLAN is also present into this MAC address table, but right now for the sake of simplicity we are not touching this. We'll talk about VLAN in our future lectures, where we'll be going in depth about what exactly VLAN or virtual LAN. But right now we'll focus on that we are dealing with 3 ports, port 1, port 2, port 3. And as we know that MAC address of S1, S2, S3 would be different. So let's say MAC address of S1, for the sake of understanding, right, we are writing 1111. As such, it is not this small. It would be a 48-bit address. But just for understanding, 1111, let's keep this thing as 2222 and this thing as 3333. So we prepare a table. That MAC address of a device which is connected on port 1 is 1111. Remember, when we said it is system 1, S1, that is what me and you are understanding. System, that the switch is not understanding it. Switch would say stop, stop, stop. S1 is what you are telling. I don't understand what is S1. I understand its MAC address is 1111. So I'm making a table, and in which I'll say that whosoever is connected on my port 1, his MAC address is 1111. See, this is the meaning. So same way, it will create rest of the table that whosoever is connected at port 2, his MAC address is 2222, and similarly 3333. This table is ready now. Now because it is made pretty fast, once this table is ready, again here comes our switch, and we have got S1, S2 and S3, right? They are connected. 1, 2, 3. Now something really interesting happens. As S1 goes to talk to S2, S1 would say, I want to talk to S2. I tried it for the first time. You send the message to S3 also. But this time, switch would say, no, my table is ready. So it will say, this message would first come to this table. So S1's message would come to this table. Now this table would be read at every point. Now at junction 3, first we'll be taking 3. At junction 3 or at the port 3, it would ask, where you want to go? Now you know this thing, that whenever we say that S1 wants to talk to S2, there would be a source IP address, there would be source MAC address, there would be a destination IP address, and there would be a destination MAC address. So it would say, I want to talk to 2222. So then table would say, but at port 3, it's not 2222, it is 3333 connected. So I don't think you need to go over there. Block. If there is fourth port where S4 is connected, in table we have got 4444 will be there, port 4. It would say, why do you want to go there? 2222 is not connected. Block. And over here at point 2, at port 2, it would say, you want to talk to 2222? Yes, there is 2222 there. Go forward. So practically it happens that now the communication is going between S1 and S2 only. Now in case if S4 and S3 they are talking, so yes, very well, they will be making their own area, they will be making their own domain, and they will be talking with each other. Got it? So it's like they both won't be disturbing each other. This is the advantage. And as we said that anything which is happening for the second time onwards, we called it collision domain, right? We called it collision domain. So we have one collision domain here, we have got another collision domain over there. This is collision domain 1, this is collision domain 2. So point is that we have got multiple collision domains, right? So we write over here as many collision domain. This takes us to the third point, the routers. How these routers act. Now if you have understood this, routers, understanding router is the easiest thing. Here is the router. Router would say, this is subnet 1 and this is subnet 2. Router would say, I won't allow anyone even for the first time also. So from here to here, it won't allow. So that means this is S1 and this is S2. They won't be allowed to talk even for the first time, because routers, they never allow broadcast. The function of router is to split the network. Split the network. So it won't allow even for the first time. So there would be a separate, this would be like a separate broadcast domain, and this would be another broadcast domain. They both won't be communicating with each other. This is the difference between router, switch and the hub. So when it is not happening for the first time, obviously it won't happen for the second time and third time also. So this is the reason that in case of our router, we have got multiple broadcast domain and multiple collision domains. So we'll write it many. That's the major difference. So in case of hub, it was 1, 1. In case of switch, it was 1, many. This was because of A6. And in case of router, this is many because it is the function of the router. It is the nature of the router to split the networks. So that's how the layers, layer 3, layer 2, layer 1, this was router, this is switch, this is hub, and for the broadcast domain and the collision domain, we have got 1, 1, 1, many, and many. If this is a switch and I connect one computer over here and one computer over here, if it is said that how many broadcast domains are there and how many collision domains are there. In Cisco, they ask you such questions in CCNN. Easiest thing to remember, whenever you are asked calculation of broadcast domain, if there is no router, so then it has to be 1, because it's the capability of only the router to split the broadcast domain, not anyone else. And then how many ports are there on the switch? We have got 1 and we have got 2. So this is, it has got 2 collision domains. Let's take one more example. This time, this is hub and we have got switch over here. We connect hub and then there are 2 devices here and here. Now how many broadcast domain? Obviously there will be 1. And collision, how many collision domains? There is only 1 port. And in case of hub, we know that even if there are 100 computers attached, hub is always like a 1 collision domain. So here it would be 1, 1, because this entire area would behave like 1 only. Okay. How about this? We have got a router, 1 router here, and this is a switch. This is 1 computer, 2nd computer, and this is another hub. Here also there is 1 computer and there is 2nd computer. How many broadcast domains are we watching? Talking about broadcast domain, so straight away we'll say that where is router? Here is the router. So it is the router's capability to split the broadcast domain. So we have, this is 1 broadcast domain and obviously this will be the 2nd broadcast domain. So we have got 2 broadcast domain. What about the collision domains? Collision domain, here is hub. So this entire thing is 1. Even if there are 100 PCs connected, they are just 1. Then between router and switch, Yes, there is one collision domain. So because we have to straight away pick up number of ports of switch. So this would be 2, this would be 3, and this was the fourth one, right? So we have got 1, 2, 3 and 4. We have got 4 collision domains. So that's how all these things, they are important. You have to just remember it this way, that in case of router, only they are capable of broadcast domain splits. Only they can split the broadcast domain. Broadcast domain, something which was happening for the first time, right? Which was happening for the first time. And in case of switch, they are capable of collision domain creations. Collision domain creations. Can router also create collision domain? Yes, broadcast as well as collision. If it is happening for the first time, so it would happen for the second time also, first time onwards. That's why I'm writing it like this. In switch, because of A6, you have got one broadcast domain and you have got many collision domain. Now there are few other things like layer 3 switch, layer 4 switch. Yes, they do come, right? They do come. What we understood was the absolute foundation, that layer 1 is hub, layer 2 is switch, layer 3 is router. But yes, these switches, apart from layer 2, even layer 3 switches, layer 4 switches, etc., they also do exist. But in order to avoid the confusion, we are not discussing that part. But the moment it is said, even in the simplest of the word, it is said that a layer 3 switch, yes, it is a layer 3 switch. So in that case, it would be having some capabilities of a router. That means, will it be able to create multiple broadcast domain? Yes, it would be able to create multiple broadcast domain. But it is a switch. Well, it is a switch, but it has got layer 3 capability. That's why it will be able to do it. Right? Okay. Moving on to our next concept for today. And that is ARP. A very, very vital subject. ARP. Address Resolution Protocol. Now when we say address resolution protocol, why is it needed? Say a question. Can you give two devices a same IP address? Same IP address? Well, if you see, the moment you try to do that, immediately it will say conflict. There would be conflict. Well, if you say that if you try to give the same IP address to devices and if there is conflict, that means everyone has got the unique IP address. And if there is unique IP address, why is it necessary to go for the MAC address, adding the extra new address, something which is adding confusion to the networking system? Now see, this is how we discussed even in the first lecture. For communication, we require a name and we require the address. So after reaching to the address, we take into consideration the name, right? So over here, this is our IP address and this is our MAC address. This is our IP address and that's our MAC address. So here is, this is a switch and I am connecting I'm connecting two computers, and let's give the IP address 10.1.1.1 and let's give 10.1.1.2. Two IP addresses. This is our S1 and this is our S2. These are the two IP addresses given. When you ping means you want to communicate, and you give ping 10.1.1.2. This is you are doing from S1. So that means S1 wants to talk to S2. What really happens now? Here is the entire process. From the point of view of S1, it'll say administrator has said that go and talk to 10.1.1.2. S1 would say that who is 10.1.1.2? I don't know. Because in order to communicate, you require four things. 1. Source, IP address. S1 would say, think from the perspective of S1. S1 would say, yes, I know my IP address 10.1.1.1. It will say, okay. MAC address, yes, I know my MAC address also. My MAC address is, let's say, 1111. Okay, to whom you want to talk? He'll say, admin said that you have to talk to the destination IP address 10.1.1.2. Admin said, okay. So he'll say, then what is his MAC address? There is the confusion. S1 would say, how do I know? So then, as per the principle of communication, it would say that if you don't have destination MAC address, you cannot talk. If you cannot talk, so then entire purpose is defeated. So then there comes the protocol. It is so similar to human beings. We also do it like this only. So now think it like that S1 has got the IP address, but there is no MAC address. And the protocol, which is called as the ARP, it does exactly this, that you have got IP address, then I'll find out what is the MAC address associated with the device whose IP address is 10.1.1.2. And this is what is called as the ARP request. Now you must have watched those Hindi movies, right? Many of the movies. They say, okay, those gundas, they kidnap the heroine, and then hero is going on the road and singing the song. And that ARP request is like a broadcast. Everyone listens. So actually it starts singing a song. And it is singing a song that, okay, where is 10.1.1.2, where is 10.1.1.2, and this is going to everyone. This is going to everyone. If there are S2, S3, S4, S5, S6, this song that 10.1.1.2, where are you, right? It is going to everyone. But well, S3, S4, S5, S6, they are Sharif. They'll say, no, we are not 10.1.1.2, so we'll not say anything. This S2 would say, I am 10.1.1.2. So it would reply. And that is what is called as the ARP reply. And this reply, because S2 knows that this shouting has been done by S1, so it would go to S1 only. In other words, it would say, okay, hey, don't shout. I am here and this is my MAC address, right? 2222. It'll say don't shout. So the point is, the ARP request, which was a broadcast, that means one to all, the ARP reply is point to point. It is unicast. So it goes like S1 is shouting 10.1.1.2, 10.1.1.2. S2 is telling, okay, this is my MAC address 2222, don't shout. This entire process is called as the ARP, address resolution protocol. Now this ARP, when this process is going on, right, it takes some time. But then what happens, that it's not so that S1 and S2 they are talking only for once. They said no, we'll be talking again so many times. So what it tells, that see, if you have to talk again and again, then every time it is not a wise thing to go for this protocol. Every time broadcasting, every time unicasting, no, remember it. So then they both agree, yes, let's remember each other's MAC address. So they'll remember their MAC address. As one would say, okay, I'll remember that 10.1.1.2, your MAC address is 2222. I'll remember. So next time when I would like to talk to you, I'll straight away use this MAC address and will communicate. This table is called as the ARP table. Address Resolution Protocol table. So once the table is there, straight away it will pick this piece of information, that is the MAC address of destination, and will communicate. So easy. Can we really see this thing? Yes, we can see this thing. Today we'll be doing a practical also, and in that when we'll see that ping 10.1.1.2, you'll find that dot, you'll find why dot means they are not successful, and when the exclamation mark comes, it means things are happy. Here it is not happy. These are failures. Why they are failing? They are not failing because ARP is not working. No, not because of that, but because ARP process was there. There was ARP request, then it responded, there was ARP reply, but then this S1 was impatient. By the time the message came, it went into what's called as the timeout. It went for timeout, and that's why this was dot. But then as it was resolved, so it said that now we'll be remembering it. So there would be ARP table, and once this entry is into ARP table, this time is not wasted, and that's why everything is successful from that point onwards. So if you try to do this thing again, right, if you ping again, ping 10.1.1.2, you'll be 100% successful, because everything is coming from ARP table. So this is one proof. The second one, can we see this ARP table? Yes, you can. Let's say if you are doing it on Windows, right, our Windows, you just give ARP-A. A is all. You'll be able to see IP address, and you'll be able to see the MAC address. You can do it even right now, even on your computers, right? Windows key plus R, it would open. You give CMD, command prompt, and you give this ARP-A, and you will be able to see the IP address matched with MAC address. Let's say you are working on Cisco routers. So then command would be show IP ARP, and there you'll be able to see the IP table. Now there are so many extra things in IP, like you can create a static entries, and ARP is important even from the security point of view. But because today we are touching only the foundation, so as we'll proceed, you'll see that there would be a day when our entire session would be only on ARP. What are the security concepts associated with ARP, and how to tackle or mitigate attacks which are associated with ARP. So that's the reason that these topics, they are like foundation topics. They are so important that at every stage they will be used, whether we know it or not. So this was about ARP. Now we said that ARP, right? Remember it like AIM, AIM. Why? Because ARP is IP to MAC. IP to MAC. So just an easy mnemonic. If there is ARP, is there anything like MAC to IP? There has to be. Yeah, and that is called as the RARP, reverse ARP. This is reverse ARP. Now, where do we need reverse ARP? Why is it needed? Because 99% of our communication is going like this, what we discussed above. In which situation it is like we know our MAC address and we don't know the IP address? Well, that is when it is also called as the diskless node or network booting. Now see, as the system starts, then from our hard disk OS, operating system, whether it is Linux, Mac or Windows, anything, it boots, and then you have got the protocols configured in which there is mention of IP address also, and systems work and they start communicating. What if we don't have the hard drive? There is no hard drive. So now we have got the network interface card. If we have got the network interface card, on that there is boot ROM, in which we have mentioned that as the system starts, this whole system should go to this specific server. Go to that specific server and take your operating system. This is what is called as the network booting. This is what happens in diskless nodes. Now in such cases, what we have got, do we have our IP address? No, we don't have IP address. Do we have our MAC address? Yes, we have our MAC address, because MAC address is hard coded, right? It's a hardware address. Right from the birth of this NIC, MAC address was there. So it would take its MAC address and will go to server and will say that this is my MAC address and please give me the information needed. This is where the RARP comes into picture, reverse address resolution protocol, though it is used very less, but good to know. Now the next is, so we talked about, say till this point, our first point was the difference between router, switch and hub. That was our first point for today's discussion. Then we talked about broadcast domain and collision domain, and as such we said that these are integrated topics, they all are related to each other. The third was our ARP, that means IP to MAC, AIM, and we talked about RARP. Our fourth topic for today is DHCP. DHCP, and our fifth topic would be DNS. So let's start with DHCP first. DHCP, and we'll do the practical also. Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol is when the IP addresses, they are given automatically. So let's say this is our switch, and if there are two computers, S1 and S2, then it is easy. We give the IP address 10.1.1.1 and let's say 10.1.1.2. Well, that was fine. But what if there are 100 computers? And giving IP address to 100 computers, that would be a pain. Going all the way 10.1.1.1, then 2, 3, 4, 5. So what if there is a system which gives IP addresses automatically, and that's the function of DHCP server. Now this DHCP is part of what's called as the TCP IP. TCP IP is what? TCP IP is a routed protocol. Last time we talked about routed and routing protocol. Briefly talking about it, routed means that protocol which you will be implementing on end devices. These are the protocols which are to be configured on every machine. This is the reason that when I am, say, using Windows, but let's say if you are using Mac, or if someone is using Linux, can they really watch this session? Yeah, surely they can watch, because all of them, they are working on this TCP IP, transmission control protocol, internet protocol. It is the routed protocol. But let's say this is my location, let's say it is L1, location 1, yours is location 2, this is location 3. So are we directly connected with those wires? No, there would be ISPs, there would be routers in between, right? So many routers in between, but still everyone is listening in real time because it is communicating so fast. So what is happening? That these routers, these ISPs, those who are here, they are having their own mechanism, and that is what is called as the routing protocols. They are the routing protocols. We'll be doing experiment practical of this also today, so that the concept of routed and routing protocol is absolutely clear. So remember, these end devices, they are configured for routed protocol, and these routed protocols, right, this is TCP IP, and DHCP is a part of this TCP IP. Let's take it this way, that here is a DHCP server. This DHCP server, so from where he has come? Well, DHCP is a service, So server is someone who gives services. So who can give this DHCP server? Well, Windows, yes, you can make your Windows server as a DHCP server. Can Linux? Yes, there can be a Linux machine who can act as a DHCP server. Can a Cisco router be a DHCP server? Surely it can. Can a switch be a DHCP server? Definitely. Why so? Because all of them, they are following the concepts of TCP IP. And this TCP IP is based on OSI layer, Open System Interconnect, OSI layer. And these OSI layers, they are the standards. They are the standards of networking. So if everyone is following the same standard, that's why it's like we don't have to worry about that. If I'm sending mail to someone, then he should also be having Windows 10, this edition or that edition. No. You don't have to worry about. You send a mail from your cell phone, it will go to someone who is having Mac, it will go to someone who is having Linux, or it will go someone who is having another company's phone. No problem. Everyone follows the same concept. What OS or the operating system is, how the device functions, how it utilizes this TCP IP, and on top of it, what do you see on the screen? And what do you see on the screen is called as the GUI, graphic user interface. Otherwise, in the core, everything is running quite similar on the same principles. Okay. So here is a DHCP server. When I say DHCP server, so yes, this is what I wanted to clarify, the concept. Because in one of the interview, when I asked this question, I said, have you ever seen DHCP server? So that gentleman said, yes. I said, can you describe it? He said, yes, it's always a big box. I said, is it really necessary to have a big box? So he said, yes, servers, they are always big. Now, you must have heard of, say, Arduino chipsets. Now these are it is like those are the computers whose size is equivalent to the size of matchbox. And yes, they can act as a DHCP server without any problem. This is the reason I talked about this, that routers, they can be a DHCP server, switches, they can be DHCP server, right? Linux, Windows, Mac, all of them, they can be. So when we say DHCP server, its function is to give IP address. So first, as an admin, when you configure DHCP services, you have to say that I have to create a scope. Scope is what? Scope means range. So let's say we create a scenario 10.1.1.1 to 10.1.1. let's say 100. These are the IP addresses which we would like to give to our nodes. So here is a DHCP server. We connect it to a switch, and this is S1 and this is S2. And we give IP address 10.1.1.200. Remember this part: servers, routers, gateways, network attached stations, all these should be given static IP address. Means you have to give some specific IP address to them so that everything functions well. Now there can be some exceptions, but this is like a general rule. So we give IP address to our DHCP server 10.1.1.200, and then we create a scope that let's start giving IP addresses from 10.1.1.1 onwards. Now this comes like first come first serve basis. So whosoever comes first, he will be given first IP address, then comes the second, so he is given the second IP address, and it goes on. Now this will make us understand one more topic. What if DHCP server is not available for some reason? What could be the reason? Cable is damaged, DHCP is down, something wrong goes to the switch. But whenever the DHCP is not available, I'll say that it is not available. In that case, all the machines, they will go for a PIPA, right? S1, S2, they will go into the state of a PIPA. And a PIPA is automatic private IP address allocation. That means 169.254.x.x. It will start picking up IP addresses from this. And when the DHCP is available, if you refresh, you will see that they have started obtaining the IP address. We'll see this thing. Okay. So let's say we watch it practically. Now for the sake of convenience and saving the time, I have just put these devices, right? See, this is laptop 1, and any IP address? No, nothing. No IP address has been given. Similarly, on this laptop, here also no IP address has been given. In case of server, say we give the IP address, let's say we give 200, right? So this is 10.1.1.200. This is the IP address which we are giving with the subnet of 255.255.255.0. We go to DHCP services. We go to services, DHCP. Right now this is off. As we said that we have to create a pool, or we have to create what's called as the scope. Scope or pool, it means the same, right? So we say that we would like to give, let's give some name, say server pool, and we give the name, say server pool 10, right? Any name can be given. And we say that our IP addresses should start from 10.1.1 255.255.255.0 and we just add to it. So now we have got a server pool 10 which is telling that start IP address 10.1.1.1 and will start giving IP addresses from this point onwards. We right now see this is off, right? Services are off. So let's wait. We go back to these laptops and we give them DHCP. Right, here is interface, we give DHCP. Now it is in search of DHCP server. See, because the services were turned off, so it got 169.254.35.6. 169.254, it is a PIPA. How it happened? Well, this is what I wanted to show, that instead of going for the theory part, first we see and then we'll go for the theory, which is just a small theory but very important. Okay, same thing even in this case. Yes, we go for DHCP and wait, it is working, but no DHCP server is there, no one is responding. So then it would say from static to DHCP, and very soon it will also pick up this 169.254, 112.180. See, a random number. This 169.254 is what would remain same. Right? So this is what is called as the PIPA. Now going back to our server and we turn this services on. This service is on. So now we go back. Here it is. See, it has obtained 10.1.1.1 with a mask of 255.255.255.0. Right? Go to second. Here it is, the next available IP address 10.1.1.2.255.255.255.0. Now, if I add one more machine, right? If I add one more laptop over here and I just connect it, and I just connect on any of the port, I connect it. This orange is because of spanning tree protocol, which is one of the concept of switch. Switch takes some time, so let's fast forward. Yeah, right, we go to this, we go to this DHCP, and here it is 10.1.1.3. So see, now this way everyone is getting the IP addresses automatically because of this DHCP. Okay, coming back to our concept, how it really happened. How it really happened that it started taking these IP addresses. You have to remember, for DHCP you have to remember these four things: D-O-R-A. Discover, offer, request, and acknowledge. This is your system machine and that's your server. So here is the first point. This is number one. First, this is a broadcast. This is a broadcast. It will shout. It will say, is there any DHCP server who can serve me? This DHCP server kicks in. He'll say, yes, I am there and these are my details. The offer, right? I can give you this IP address. So then our client, it will come in requesting mode. It will say, acha, so please give me IP address. And the server would say, no worries, done. You are having it. So that's how This is the discovery, which is a broadcast. This is offer, this is request, and this is acknowledgement. Actually, you can see all these processes. So step by step. Why DHCP is important? Because DHCP is giving IP address. Well, it is fine, but what if instead of this Sharif DHCP, there is some rogue DHCP? This DHCP who is not genuine, right? It is some hackers DHCP. So now he'll be giving wrong IP addresses, he'll be giving wrong gateways. So that's the reason that in security, DHCP server is also very vital. You need to protect your DHCP, because see, your DHCP server is giving IP addresses to not 1, 2, 5, 10. It is giving to hundreds and thousands of your devices which are across the network. So that's why it is necessary to protect. This is the reason this topic was taken as a foundation topic, understanding it. Now in this only, one more important concept, if you must have noticed, that as I said, the DHCP discovery is a broadcast, right? It is a broadcast. Now which was the device which was telling that no, I won't allow the broadcast to pass through me? Well, it was a router, right? It was router. Router never allows broadcast to pass through it. So what if situation is like this, that here is a router, here is our switch 1, this is switch 1, this is switch 2, and we have got the DHCP server over here, and here we have got all the devices, our S1, S2, etc. So they all are happy, right? Because they will be getting the IP address. But as we said, this is a broadcast, so it will remain, this entire broadcast will remain over here only. So then what's the fault of those bichare devices over here, right? Let's say they are, say, D1, this is D2. Now these devices would say that, sir, we also want IP address. Who will give us IP address? Right? DHCP server is over here. DHCP server would say, well, no problem, I have got the IP addresses for you, but at least you talk to me. If you don't ask, how can I know? But they will say, yes, we are shouting that please give IP address. But what is happening is that this router is telling, no, I won't take your shouts, I won't take your broadcast on the opposite side. So now what to do? Solution 1. We deploy a person. We tell him that you listen to our demand and you take this demand to this DHCP server, and then you give the IP address. Fine. And in that case, this is called as the DHCP relay agent. DHCP relay agent here. So it means that when you are in another subnet, this is subnet 1 and this is subnet 2. When you are in another subnet and you really want to use this DHCP services, so then you require a DHCP relay agent. Can this work be given to router also? Yes, it can be given to router with the help of commands like, with the help. So command is also like IP helper address, right? Those things, they can be done. All right. Now let's see a small network where we'll compile everything whatsoever has been learnt. So here is our router 1, here is our router 2. We connect both these routers by a switch. Then we connect one more switch over here, and with this switch we connect one device, laptop. There is one more switch over here and we connect one more device over here, right? So we have got switch 1, switch 2, switch 3. No configuration would be necessary on switches at this point of time. because we are just configuring the what's called as the routing. Now, as you know that routers, every port has to be on separate subnet. So let's say 192.168.10.0/24. This is one network. So we make another network 192.168.20.0/24. So this would be a separate network. This is a separate network, and our third network, let's put it 192.168.30.0/24. So third network, correct? We give IP addresses. Let's say this would be .1, this would be .1. .1 means what? It would be 192.168.10.1. This would be 192.168.20.1, and this would be 192.168.20.2, and this would be, let's say, 192.168.30.1, and we give IP addresses to our laptops. So let's say 192.168.10. let's say 10, and this is 192.168.30.10. So these are the IP addresses which we give to our nodes, right? Let's configure this thing, and we'll see that if we try to ping, so then ping will stop at this point, considering this is our A. So when we'll try to ping 192.168.10.1, it would be successful, but it won't be able to cross. What is to be done if we really want to say A to talk to, let's say this is B, A to talk to B, we require routing. And in routing there are several protocols. So we'll see that how to do it. First, just have a look at our configuration. Here it is. Again, to save time, I have just kept the devices. None of them has been configured, right? This is switch. No need to configure. This is a router. All the ports are down. This is absolutely just the beginning, right? We just give, say, no over here, and we have to configure it, right? So there is no IP address given, nothing. Only in cases of these laptops, say I have just given 192.168.10.10. Yeah, this is the IP address which I have given to laptops, right? 10.10. And over here, let's see if we have given this IP address. We have got 30.10. Yes, IP address has been given over here. So only on laptops we have given IP address, just to save some time, right? And what we shall be doing on routers. Now here it is. For router, I'll explain this thing. See, this is gig 01 port, this port where the pointer is, right? This port. This is gig 0x0, or as I was talking about this part, right? See, this we have already given. So we'll be giving 192.168.10.1 on this port, and then we'll give 192.168.20.1 on this second port. So this is gig 0x0 and this is gig 0x1. So we'll give IP address to them, and similarly we'll configure R2 also. And when we do this thing, right, this is our R1 and this is our R2. So 192.168 is common. So over here it is .10, in between .20, and over here it is .30. So this would be 20.1, 20.2, 20.2, this would be 2010.1, and this would be 1030.1. Okay, coming back to our configuration. So here is the IP address, config T, right? We'll go into config mode, we'll give the host name R1, interface gig 0 by 0, IP address 192.168.10.1, and no shut, we are opening the port. Similarly, for this second port, which is gig 0 by 1, we give the IP address 192.168.20.1, 255.255.0, and we open the port. We exit, and then this is router RIP. What router RIP is? Router RIP is one of the routing protocols. Now see, we just configure this much, configuring only the IP address, right? We just copy, we go over here and we just paste this configuration, enter, and we just give exit, Control Z, and if I give show IP interface brief, so yes, it is showing me that IP addresses are fine, they are up, right? It is 10.1, 21 IP addresses, they are there. Similarly, I configure this part, second router also, and over here this is enable config T, the IP addresses they are given 20.2, 30.1, we just copy it and we paste it over here, and then we check whether the IP addresses they are good, right? And we give show IP interface brief, and IP addresses are there. See, giving only IP addresses, that is not sufficient, because if we try to ping, right, we go over here and let's say we ping 192.168.10.10. Now see, destination host is unreachable because that router is telling that no, you can't cross it, right? Now let's say same thing, if we say can we talk to 30.1, can we talk to 30.1, it would say yes, 30.1, you are just my gateway, I can surely talk to you, but we want that this B should talk to A, and for that will require what's called as the routing, right? And for routing, this is a small portion that so that we know that where exactly we stand. Routing is divided into as such two parts. One is what is called as the static routing, and second which is called as the dynamic routing. Static means it is fixed, manual. This is a manual routing. And dynamic, where it is done automatically. You have to just tell the router that which protocol you want to follow, and you have to give the network addresses, and it will create the tables by itself. So in dynamic, two concepts, one what is called as the distance vector, and second it is called as the link state. Now those link state, they are like OSPF, EIGRP, right? They are all advanced routing protocols. Today for the understanding, we are picking up this distance vector routing protocol. So in distance vector, we are taking RIP, routing information protocol. This routing information protocol will take version 2. This is what we'll be using. Now see, in configuration what we have to do. In configuration, as I said, that you have to mention that you want to use router RIP, so you will say router RIP version 2, so that is router RIP version 2 would be used, and you don't have to install any of these protocols, they are all inbuilt. You have to just say in configuration mode that yes, we want to use this routing protocol, and then you have to mention that this protocol would be acting on which networks. So that is where you will say that I wish that this RIP should be acting on, now see, this is the talk of R1. So on one side we have got 192, 192.168.10.0, right? On this side it is 192.168.20.0. So R1 would say that I wish that RIP should work on this network also and this network also. So 192.168.10.0, and same way network 192.168.20.0. So that's what we said. This is how R1 would say. When it will come to R2, R2 would say, well, R2 would say that on my side, so this is network 20 and on this side it is network 30. So I will also run rep. I would also like to run rep. But in that case, I would say that, okay, network 20 and network 30. When I'm writing 2030 means 192.168.20.0 and 30.0, right? So that way, and when R1 and R2 would be talking to each other, they would exchange these information, right? They will say, R2 would say, I have got network 20, I have got network 30. R1 will say, I got network 10, I have got network 20. Both would say, acha, 2020 is common. So why don't you give me your 30 network over here and you take my network 10 over there? They'll say no problem. So now everyone knows about all the three networks. So this is the reason once this table, it is called as the routing table. Once this table is ready, now this is completely transparent to users. So over here it is the user B. Now he'll innocently say, Acha, can I talk to 192.168.10.10? So this will say, okay, let's go to gateway. R2 would say 10.10, right? This is network 10. Yes, network 10. So for that I have to send you to R1. So he'll say, okay, go to R1. R1 would say, Acha, network 10. Yes, network 10 is connected to me, and he'll reach to this A. But he'll say, where is this A? There might be 100, there might be 200, there might be 400 computers connected. So he'll say, okay, where to find out A? This is where that song would come in, song of ARP, right? This port would shout that where is 192.168.10.10? Reply. And then A, this our A would say, here is MI, and it will reply in unicast. So now router 1 would be having IP address and the MAC address, both the things, and the packet would be delivered. So let's do this thing. So at this point, we saw that it was not communicating, right? When we gave ping, right, our let's say ping 192.168 say 10.10, right? It is not working, and that gateway was working. Okay. Configuring router rep. So here is router rep version 2, and these are the networks. This is from the perspective of R1. We just copy it, go to router. It has to be given in config mode, so we just give config T, and then we fire this configuration. All right, we just give exit, Control Z, show IP route. Yes, it is showing that there is network 10 and there is network 20. Happy. But where is network 30? You'll say, I can't talk to R2. You configure R2 also. So we go to R2 and we say, R2, here is router rep version 2. You have got network 30 and network 20. So let's configure. We give config T and we paste this and exit, Control Z, and we give show IP route, and here it is. It says, yes, this is 20, this is 30, but where is 10? Well, they both are talking. After 30 seconds, they'll say, Acha, you take my network 10, and this router 2 would say, you take my network 30. They are talking, right? Let's see if their talk is over or not. Here it is. Their talk is over. They have communicated. Here is R. This R is indicating that router 1 has learnt 192.168.30.0 via this RIP version, right? If we give show IP protocols, so in that routing protocol is RIP, and this is routing for networks is network 10 and network 20, and over here say our gateway, and this is 120 is administrative distance. Right now we are not worrying about it, but over here this is RIP is something which is in action. Now same way, if we go to our second router and we declare that chalo you show your routing table, show IP route, and it says yes, here it is. I have learnt 192.168.10.0 from via this RIP. Now it is ready. Let's go to this, the ping which was not successful. We fire that ping 192.168.10.10, enter, and it is waiting. Timeout and done. The first was timed out. We tried to do it again. This time it is 100% successful. But why wasn't it successful over here? What was happening? What really was happening was that ARP process was in process. It was the ARP which was taking time. ARP, address resolution protocol, it went for ARP broadcast, then it went for ARP reply, and it procured its MAC address, but important time was wasted. In fact, important time passed by, so it went into timeout. But now ARP table is ready, right? So what if I give ARP-A, here it is. It tells that see 192.168.30.1, and this is the physical address. Now I have remembered it. It is into my table. Will it happen at every level? Yes, it would happen at every level. So if we give show IP ARP, right? If we give show IP ARP, here it is. This is the ARP table. This is the ARP table for router 2. Router 2 would say, yes, I am remembering 20.1, 20.2, 30.1, 30.10, every one I am remembering, right? I am remembering every one now. Everyone's MAC address is with me. So no worries. Over here, ARP-A, here it is. So everyone remembers everyone now. That's the reason that things would be pretty fast and there won't be any lag now, right? Say show IP ARP, and here it is. The entire table is ready. So these are the tables. They are called as the ARP tables. The concept of ARP table, the concept of DHCP, they are so vital because so many security services and so many mitigation systems, they are based on this. I take you to one more thing, and that is the DNS. Very interesting things are in DNS. DNS, which is also called as the domain name services. Domain name services. Now you go on internet and you type, say, cisco.com. Now it's not easy to remember. Say this domain name services, right, this DNS, say it is not easy to remember, say, cisco.com's IP address, but this is a friendly name, a name which can be remembered by us. But what would be the IP address? That IP address would be a live IP address. So function of DNS is a link. It's a link between the addresses which can be remembered by the machine and the human being. So we remember these friendly name, and these are the IP addresses of that particular domain. So DNS is a link between both of them, the link between name and the IP address, and that's why they are also called as the NS servers. NS servers, their NS stands for name services. Name services. Now see, this name services, they have got so many utilities. There would be, I would like to show you those things. Like say there are records. There are records. NS records, that means name services record. Name services. Then there would be something like MX record. MX means mail exchange. So where you can deal with those machines which will be handling your mail servers. Now it happens like say DNS. It's a very heavy process. So you might have deployed 1, 2, 3 machines. NS1, NS2, NS3, 3 machines. All of them, their function is only one, that is resolving cisco.com. Anyone from anywhere in the world, he wants to resolve this cisco.com, so in that case these machines would help. But because the load is so high, that's why it has been distributed across several machines. But then when you have got so many DNS servers, who would be the first one? So that one is called as the SOA, start of authority. So we'll be able to see even that also. For looking at all these things, the command is nslookup. nslookup. NS stands for, as we talked about, name services. So name services lookup is the command. Now instead of discussing theory, straight away we'll see it practically, right? Okay, so here it is, and again to save time I have typed these things, so it would save some of our time. Okay, here it is. So let's start with nslookup cisco.com. See, it is telling that it is 72.163.4.185. So if I type this IP address into my browser, yes, it would reach to cisco.com. But then how about knowing which are the servers, right? Here it is. It says that there are 3 servers. Currently there are 3 servers, NS1, NS2 and NS3. Their whole name is ns1.cisco.com. It is fully qualified domain name. It is called as FQDN. These are the names, right? And these are the unique names. So ns1.cisco.com is a unique name. 2, 3, they are the unique names. Out of these 3 servers, which server is the start of authority? So in that case, what I would do, I would say nslookup dash type is equal to SOA. Over here it was NS. NS was name services. Now it is SOA. That is, out of all those name servers, which one is the authority? And we say that okay, it is the primary name server is ns1.cisco.com, and responsible mail address postmaster.cisco.com. This is the serial number, refresh, retry, expire, right, default time to live. These are the details which you get, and this is for this main server. He is your SOA, start of authority. So now in that case, we said that DNS, it can be handling even mail exchange queries. Yes, it is called as query. So I'll change the command nslookup dash query is equal to mxcisco.com, and when we check it over here, here it is, right? It is giving us that these are the mail exchanger airmx-01.cisco.com, rcdn-mx, all these are the mail servers. Now if we go into the detail of this, say nslookup cisco.com, so over here we saw that yes, there are three servers, ns1, ns2, ns3. What if I want to dig deep into this and I want the information of this ns1.cisco.com, right? Here it is, we give nslookup cisco.com ns1.cisco.com, and here it is. This is, by the way, IPv6 address, and this is the IPv4 address. Over here ns1, this is 72.163.5.201. see, this is one server, right? Now when I go into the detail of this and I go for the detail of second server, ns2, see, its IP address is different, right? This is 64.102, this was 72.163, and when we go for the third machine, third server, it is 173.37.146.41, right? So these are the real live IP addresses of these servers. Now can I check it? Yes, you can check it. Say I give nslookup and we pick up the IP address of, let's say this, we take this IP address, we just copy paste it, right? So in that case, it should resolve to ns2.cisco.com. Let's see. Here it is. See, it resolved to ns2.cisco.com, right? So this is what is called as the DNS. So what we really learned during this entire session was that there are some concepts which are very vital in case of networking. There are few even more concepts also, but starting with these concepts, where we'll go step by step more and more into the details of further say topics. But one which was broadcast domain and collision domain, we talked about, say, routers, switch and hub. We talked about routing protocol and we saw that how they work. We talked about DHCP and we talked about DNS. Now this is like not end of the subject, end of the topic even for these, right? There are so many things involved into, say, DHCP, DNS, routing protocols, so many protocols. So step by step we would understand all these details of the topics as we proceed further. Today's idea was that these are the foundation and so many security features and the security implementations, they are associated with these topics. Thank you so much, and we meet again very soon.